So today I'm going to show you how to do a simple seepage analysis for a homogeneous earth dam with conditions that look like this. So this is your plain simple dam. You've got one type of foundation material on which the dam is seated. You've got your K values, so your dam's less permeable than your foundation. You have a water table at 18 meters elevation, and you've got nothing on your downstream. Very simple, very basic. So to do this, we're going to be using Slide, and Slide is part of the Rock Science suite of programs. It's a slope stability analysis software, but it also includes finite element groundwater seepage analysis, which is what we're going to be using to do our seepage modeling. So the very first thing you need to do is add an external boundary. So you can do that by choosing Boundaries, Add External Boundary. There's several options for choosing or for drawing your boundary. You can point and click with your cursor and draw it manually. You can also use this button just to choose to add your external boundary. Your second option is to key in your vertices down here, one by one, or my preferred option, you can right click on the blank page, choose Coordinate Table, and then you can enter all your coordinates in one go, like so. So you want to make sure that your first and your last point is the same, so that you actually have a closed boundary. And the other thing you might notice is that I added a point here that wasn't on the original drawing. This is at an elevation of 18 meters. This is just where the water level intersects the upstream face of the dam, and we'll need that point later on. So I've added it here. And then you hit OK, and there's the outline of your model. So next we need to add a material boundary to separate our dam fill material from our foundation material. And to do that, you just select the two corners of the dam, hit enter, and now you've got the two different material zones. To choose your materials, you go to Properties, Define Materials, and then Material 1, we'll call it dam fill. You don't need to change any of these other parameters here. They're all for slope stability analysis. But if you were doing slope stability analysis, this is where you would choose your strength functions and enter your values. For material 2, we'll call that foundation, and then hit OK. Now we're still in slope stability view, so we'll go to Analysis, Project Settings, and then over here in the tree we'll choose groundwater, and then from the drop down we'll choose Steady State Finite Element Analysis. You don't need to choose any of the, or change any of the other options. Hit OK. And now you'll notice there's this drop down menu here, so we'll switch to the groundwater mode. And we'll choose Properties, and now we have the option to define hydraulic properties. So for the dam fill, we'll change the K value to 1 times 10 to the negative 6, and leave everything else as is. And for the foundation, we'll call that 1 times 10 to the negative 5. There's different model functions you can use, but we'll use a simple one for now. Hit OK, and then back to Properties, Assign Properties. You can assign dam fill to the dam, foundation to the foundation area. Exit out of that. And now we'll choose the mesh setup option. And you can enter a different number of elements that you want to use. So the more elements, the more calculations the program does, the more data you'll get, or the more defined data you'll get. We'll go with 3000 now. We'll leave 3 node triangles as is, and then you want to hit Discretize, Mesh. Now you've got your mesh generated. Hit OK. So now we have our mesh. We need to define boundary conditions, because they're all undefined right now. So we can choose Set Boundary Conditions, and we'll use total head for the reservoir. So we've got 18 meters of water elevation, and we'll apply that to the upstream. And you'll notice that because we added this point up here before at 18 meters elevation, the line truncates there, which is why we added it, so it's not the entire upstream face of the dam. And we'll apply it to the foundation area. Apply, close, and that's it. You don't need to do boundary conditions for any of these, as the computer will assume they're initially unknown and generate them based on this water pressure over here. The last thing we'll add before we run the model is discharge section. So we'll go discharge, add section, choose the top downstream corner of the dam, select the bottom of it and the foundation, and hit enter. You'll see a faint green line, and that's your discharge section drawn on. So now we save the model. And you can go to Analysis, Compute. Then you can go to Analysis, Interpret. And there's your model. So you can see from our discharge section, it calculates the cubic meters per day of discharge, the majority of it coming through the foundation rather than through the dam. The pink line here is the piezometric surface. So you can see the drawdown through the dam core. And right now we're looking at the total head. You can also look at pressure head if you wanted to, but we'll stick to total head. And add flow vectors. And the other thing you'll notice, I already had the program open, so the contours are already defined with black lines. But if you want to add that, you can go to Contour Options, right-click on the screen, Contour Options, and then choose Filled with Lines. Usually it's just filled. Once that's done, and then you go to Groundwater, Lines, Add Multiple Flow Lines, and you choose the upstream side of the dam, 3 corners again. Enter, and then we'll choose the first option and change that to 20. Okay, so at 20 locations along that face, it will generate flow lines. So now you basically have your flow net generator for you by the computer. You can see where the your flow is predominantly through the foundation, which is more permeable. Makes sense. You see your discharge. If you wanted to, you can add your flow vectors again. And you can view different modes. So if you want to see the velocities, but predominantly you're just going to be using total head or pressure head. The other thing to note is you can right-click on any of the flow lines if you want to delete them, like individual ones, or you can right-click on the contours themselves, and you can just change display options if you want to make your flow vectors darker, for example, or you want to remove discharge sections. And that's a very basic introduction to seepage analysis with slide.